In this screencast, we are going to talk about two reactions of amino acids. We're going to talk about oxidation and peptide formation, and then we are also going to discuss some important peptides. So, amino acids can undergo reactions characteristic of any functional group in the molecule, and this includes reactions of the carboxylate group or the amino group or any other functional group in the R side chain. However, two reactions are really of special interest because of their influence in determining protein structure. Cysteine is the only sulfhydryl, which is SH containing amino acid. So when we talk about cysteine, it contains like these sulfhydryl groups right there, and those are SH. And what we know from section or chapter 13 is that a sulfhydryl group can easily be oxidized to form a disulfide bond. So what can happen then is that two cysteine molecules can react through oxidation to form a disulfide bond. And a lot of times this is called like cysteine here. That's an older nomenclature, so sometimes you'll see it. But really we just talk about these being disulfide bonds. We see this in hair relaxing and perming. And so, for example, if you are doing hair relaxing, you've got these disulfide bonds and they can be reduced because once you make this, you can reduce it back. It can be reduced and you have these free sulfhydryl groups again, and then they can undergo oxidation and stay kind of straight like this. Perming, which kind of goes the other way, right? You would go this way and do a reduction, and then you would curl it around curlers and then go through and do the oxidation to get it back to the disulfide bonds. So this is a place that we see this particular reaction in kind of everyday life. Now, the second reaction, which we're going to spend quite a bit more time on, is peptide formation. So in chapter 16, we talked about that amides could be thought of as being derived from a carboxylic acid and an amine. Although in actual practice, we talked about acid chlorides or acid anhydrides are generally used. In that kind of same hypothetical way, it's possible to envision that a carboxylic or carboxylate group of one amino acid reacting with the amino group of another amino acid, and this would give you two amino acids that then could be linked, right? And I'm going to show you an example on the next slide, but before we do that, I want us to get some definitions. And so when you link two amino acids, you form a dipeptide. So a dipeptide is just compounds formed when two amino acids are bonded by an amide linkage, right? And so a lot of times this is called a peptide linkage or a peptide bond. And so when we're talking about a peptide linkage or a peptide bond, that's just an amide linkage between amino acids that results when the amino group of one acid reacts with the carboxylate group of another. So let's look at some examples of dipeptides that have formed. And so when we look at the dipeptides, we have glycine here and alanine here, and they've reacted to form a dipeptide. And when we look at this, this is right here is referred to as the peptide linkage, which is basically when we're talking about the reactivity, we've got this O- reacting with this NH3. And so that's the peptide linkage when we talk about it. It's the amide bond. So remember, that is the amide functionality there. Now, when we name dipeptides, we read these left to right, and we use either a 3-letter code or a 1-letter code. And so I'm going to use the 1-letter code, and I'm going to say, hey, look, we put together glycine, and so it's GLY, and then we use a dash, and now it's alanine, ALA, and those are the 3-letter codes. Now, you don't have to memorize the amino acids. I'll give you a chart on the table, but I would expect you to be able to recognize the amino acids and write the 3-letter codes as you go through. Now, it's important to understand that you can also make amino acids by linking them the other way. And so alanine could come first, and so then you could have ALA-GLY as your peptide there. Now, we can also, once this peptide linkage has occurred, we can make another peptide linkage and make a tripeptide. And so if you come over here, I'm showing you the tripeptide here. And so this, for example, would be ALA-GLY. And now we've got a new peptide. And so when you're thinking about a new peptide, the way you want to classify it is by looking at the R group. And so if you can take and compare the R group to the tables that you saw, you would see that this is valine. And so there we are. Val is the 3-letter code there. And you don't need to memorize the 3-letter codes. Those will be given to you as well. So I want us to get some definitions or working definitions as we talk about peptides and proteins. So peptides are just an amino acid polymer of short chain length. A polypeptide is an intermediate chain length polymer with less than 50 amino acids. Now, a protein has more than 50 amino acids. Now, here's the deal. Scientists disagree on where the cutoff is between a peptide and a polypeptide. And so these terms really are used interchangeably. When you have under 50 amino acids. But everybody can pretty much agrees that once you get above 50 amino acids, that's a protein. Now, when we talk about an amino acid residue, that is just an amino acid that is part of a peptide, polypeptide, or protein chain. Now, by convention, it's important to recognize a few things. One is we have an N-terminal residue. And so when we talk about the N-terminal residue, that is the one that is written to the left, and it has the nitrogen charge here. And then we talk about a C-terminal residue, and that is just the one that is here with the carboxylic acid. And so these amino acids are written from the N terminus to the C terminus. And that's the convention that we use when we're writing these polypeptides. Now, let's look at some important polypeptides. And we're going to start with two. We're going to start with vasopressin and oxytocin. So these are hormones that are released by well, let's pretend like I can spell released. Released by the pituitary gland, okay? They are referred to as nona peptides, which means they have 9 amino acid residues. Right? And the 6 of the residues are held together in the form of a loop with a disulfide bond. The disulfide bond in these hormones is formed by the oxidation of cysteine, which you can kind of see right there. Right, there's that oxidation of cysteine in the 1st and the 6th position, and so that's what causes it to make a loop. In peptides and proteins, disulfide bonds that draw a single peptide chain into a loop or hold 2 peptide chains together are called disulfide bridges. So we're going to talk about disulfide bridges again. So I want us to get a good definition for that. This is just the bond produced by the oxidation of these SH groups on 2 cysteine residues. Now, these bonds are loops, right, are going to hold the 2 peptide chains together. Okay. Now, so the structures of the 2 only really differ in the 3rd and the 8th amino acid residues, and those are highlighted for you here. There's the 3rd and the 8th, and that's how they differ. Now, when we talk about this, vasopressin here is known as an antidiuretic hormone. Because it reduces the amount of urine formed. Right? And so what that then does is conserve the body's water. It also raises blood pressure. Right? Now, oxytocin causes the smooth muscles of the uterus to contract. And it's used a lot of times to induce labor. Okay. It also acts on the smooth muscles of the lactating mammary glands to help stimulate milk production. Now, another important peptide hormone is adrenocorticotropic hormone, which is abbreviated as ACTH. It's synthesized in the pituitary gland. And contains 39 amino acid residues. It doesn't have any disulfide bridges, and it regulates the production of steroids in the cortex of the adrenal gland. Now, there are other peptide hormones that are important, and they are listed here. Do not memorize these, but I like to show these because there may be something here that you're particularly interested in. For example, you may know somebody who's diabetic, and so you're really interested in the fact that insulin is one of these peptide hormones, and that's, of course, formed in the pancreas, or you may know somebody who's had to take human growth hormone, or any of these different ones. And so it's just a really interesting list to see that these small peptides or proteins do act as hormones, and they do change things within our body. So this ends the second screencast of this chapter. We are in the next screencast going to have our introduction to proteins. As always, if you have any questions, please feel free to stop by my office.